Now it is my pleasure to introduce to you Sam Sharma. He is from Region 1, and he is a senior traffic manager for the traffic unit. So, Sam, welcome.
Thank you, Diana. Hi, everyone. As Diana already mentioned, I'm Shyam Sharma, Senior Traffic Manager. I was in Region 3 for almost 11 years, and I was traffic manager there. And 2.5 years ago, I moved to Region 1, looking for more challenges, and still missing our friends and colleagues from Region 3. Region traffic units typically consists of the design side and operations, investigations, and safety side of traffic unit. The design side includes sign design, signal design, illumination design, traffic control plan design, striping, and that area. And the investigations, operations, and safety side includes the signal timing, signal system coordinations, ramp meter operations, ITS operations, safety investigations, operational investigations, a lot of things you can imagine about traffic operations, safety, and investigations. Mostly today, I will share the design side of traffic unit, how that group involves in project delivery process with cross-reference to operations and safety side of traffic. These marks here indicate in that project delivery life cycle where the design side of traffic unit typically gets involved. We start pretty early. Sometimes we even start before scoping because we in traffic provide the business cases also for various operations projects as well as all the safety projects. And the traffic units gets involved in the desk scoping level before we get even 300% list for the projects. So these are mostly how the design sides get involved in various milestones. In project initiation phase, we need to start getting data, and we would like to get data early enough so we can start the analysis. We need to capture the traffic data in the right window because we need to capture the 30th highest hourly volume, what we call design hourly volume. If we do not capture the right window, for example, the project starts sometimes in September, October, then we miss the right window during the summertime to capture that right data. And in the future analysis, we don't want to do too much of seasonal variation adjustment, or we don't want to work with the wrong data. That's why sometimes we start early, even before the project kickoff in collecting traffic data. And we need to perform intersection control evaluations, like what we call ICE. And also, we do alternative analysis for several intersection controls. I'd like to share you one story here regarding the data. Why I'm saying that right data is important. South Medford interchange, the design started sometimes around 2006, 2007. Somehow, ODOT, we all missed the peak 15-20 minutes of traffic in the morning hour. Overall, the traffic data was fine because the critical volumes, all the volumes were PM peak hour volumes. But between 7:45 a.m. and 8:05 a.m., that's when the school started, all the doctors' offices started, and all other businesses started. Everybody gets off the freeway at that time, and that 15-minute window really caused, we didn't capture that. And I believe the problem is still there. We still see very random overflow up to the freeway off ramp. That's where having that right data is really critical. And we need to capture the data when schools is in session, depending upon what the nature of the project is. That's why what I'm saying, the right data. If majority of the project is pedestrian bicycle related project, then we need to have that type of data. So the design hourly volume always may not reflect what happens within that hour. And why I'm sharing this is the level of congestion and the perception of congestion is very different compared to region 1 and region 3. In region 1, we are accustomed to continuous congestion, but in other regions, if there is just 5 or 10 minute window of extreme congestion, it becomes serious congestion for them. So when we start draft DAP, the traffic unit likes to do the traffic analysis in the early stage of the project, so the roadway unit can use that information and they can design how long is the turn lanes required, how many lanes we can close during the construction, and all this capacity and queuing analysis. What we do is the information for roadway design. And we also need all the traffic analysis for temporary traffic management. Temporary traffic management is, depending upon the nature of the project, the traffic management plan, it could be a very simple, couple of pages of document, and compared to a very complex document. Imagine closing I-5 Columbia River Bridge for 2 weeks. What level of traffic management plan we need to have to accommodate all the travel, all the demand there. And it would be one of the most complex traffic management plan, because we need to know what will be the impact on the parallel routes. We need to know what will be the impact on the critical interchanges, and if the parallel routes cannot accommodate that need, then we have to work with the transit. We may have to provide shuttles. We may have to be very creative, like using the freeway soldiers for peak hour running of buses. So it involves a lot, and at the same time, we need to involve our community partners, and we need to involve our community outreach group. And if our communities, and if we do not provide enough information to our commuters, they will like to stay in that, and we try to avoid them. We'd like to stay away, keep them away from that impact. So this can be pretty complicated. That's why sometimes the traffic management plan, what I'm saying is, it will be very simple for a very simple rural area project where there is not much to do, compared to very complex in an urban congested environment. And we provide TPAR, Temporary Pedestrian Access Route, and which is part of Temporary Pedestrian Access Route Plan, TPAR. And work zone decision tree, since last 3-4 years, it has been a very standard practice, and we start from the scoping stage to continuously revising, updating it all the way through construction. One part of traffic analysis is highway capacity analysis. We need to know what the capacity of that highway or work zone is, and if the capacity is higher than the demand, obviously we can accommodate that, but many times when we close the lanes, the capacity will be significantly reduced. typically 1,500 cars per hour per lane is considered to be a free flow threshold, which means if we can keep under that per hour per lane, I'm talking about 1,500 cars, not 1,500 vehicles. If we have that, typically we get uninterrupted flow. However, if the demand exceeds that, we get into the interrupted flow condition. When interruption occurs in the flow, the capacity itself decreases because everybody starting from the stop. That's where, at that time, the capacity can reduce to 1,200, 1,300 passenger cars per hour. And if the demand in the consecutive future hours is not less than that, then we may not even able to clear the queue entire days, I don't know how many hours, depending upon the traffic. So that kind of analysis, we need to know when we can close the lanes and when we cannot close the lanes. That is why the management of traffic is so critical. Typically, the ODOT practice is to work in the night whenever possible to minimize the impact to the commuters. And although the nighttime traffic volume is less during the night, driver and road user characteristics is very different. All in the night, people see it just signs and barrels. They don't see what else is going on, and their cone of vision is so limited with the direction of the headlight. That's why we need to be extra careful on delineating properly how we can manage our traffic during the night. And retroreflectivity is a key issue for the nighttime driving. One thing we need to be aware of, why I'm bringing it here, daytime and nighttime traffic, is if we are closing freeways, we may not want to reroute that traffic to local streets, because the driver characteristics on the freeway is very different from the local characteristics of road users. We try to divert the freeway traffic more or less towards freeways or arterials, because that's where we can accommodate them. Otherwise, if we try to mix that with the local traffic, there are unintended safety consequences. So we need to be aware of that too. And when our traffic control plan designers design the detour routes, those items need to be, we also consider those areas or issues. One thing about management of traffic is it is very project specific. For example, if a bridge has to be built in one piece, there is no way you can fit in the traffic there. So you have to build the detour ones. And also, if there is no space if there is no cost, there is no budget to build detour, and if cost is too prohibitive, or if there is no space even to build, then we may have to close the entire freeway. Until a few years ago, we never thought about closing freeways. Recently, we have tried it, because it's really the issue of how much does it cost and who pays the cost. Is it too much impact to the community, or can we afford that cost? Ultimately, someone has to pay. Either the community pays, or the system, or ODOT, who is building the facility, has to pay. In management of traffic, pedestrian and bikes are also key part of traffic management. Traffic control plan designers provide TPAR, what I said, temporary pedestrian access route, for construction staging. Sometimes choice of construction material may be affected by the ability to provide TPAR or not. For example, if we have to open that for immediate traffic, probably concreting may not be an option, because it requires time to set up, the concrete to set. we may have to go for asphalt. Or sometimes we may have to close the entire vehicular lane to allow for pedestrian, because this is a requirement. We have to have T-bar. So it really depends on the space, how much space we have. And also sometimes we may not have even any space. We may have to go behind the building, get temporary easement and reroute the traffic behind the building. And we have also done that in Region 1. That also sometimes, issue of concern. And when there are no options or nothing, we may have to provide shuttles, because we have to accommodate them. And imagine with the existing workload and existing resources, 2 or 3 years ago when this T-PAR was added as a part of the temporary traffic management plan, there was a lot of workload added to the traffic designers. So something it came, and we have to absorb it. The second part of traffic analysis is safety analysis. In ODOT, we use Safety Priority Index System, SPIS, to identify and rank high crash locations. What exactly the SPIS score is? It is a weighted average for number of crashes occurring, what we call frequency of crashes, the crash rate, and the severity of the crashes. So 25% of the weightage is given to frequency, 25% weight is given to crash rate, and 50% weight is given to crash severity. That's how we rank those locations, and I don't know what is happening. That's how it provides the SPIS score. And when we have a SPIS score, for example, of 5% SPIS location, top 5% SPIS location compared to top 10% SPIS location, is that top 5% SPIS location is more worse, and it's more qualifiable for investing safety funds. And when we do the traffic safety analysis, we provide the information on where the crashes are occurring, why they are occurring, and what's the patterns of those crashes, and can we mitigate those? Please note that not all the crashes can be mitigated through engineering measures, because we know not all the crashes. We have 3 E's in traffic engineering, what we call engineering, education, and enforcement. When all these 3 E's, when we all work with the 3 E's and we still cannot avoid that crash, what happens? The crash occurs, and we have to rely on the 4th E, which is emergency management. So I'm talking about traffic crashes mitigable by engineering measures. That's where we are focusing on. For other measures, there are other ways to mitigate. The ITS device locations, we need to know in advance where they will be located, because without knowing them, we don't know the footprint. And many of those ITS devices could be overhead bridge or cantilever structure. And the early we know the impact, the location, the better we will be informed, because we have to prepare all this information to get ready before DAP. And one thing I would like to note here, it's a very small thing, the cabinet. Our traffic engineers, I'll share you a story. They would like to know where the orientation of those cabinets they want to put, because imagine they are doing a signal timing with that open cabinet. They are looking at the signal. They would like to see from the right window when they are playing, how that signal is functioning. That's why I'm just putting it here, because it's a preference, but it helps a lot for them to do the work. Because every little thing we think about others, that's where we really win the heart and soul of other people. We, as a traffic we as a traffic engineers, if we don't see how the transportation project managers think through the project and how we can provide the information at the right time for them, that's where they get really feel served. That's the goal. In the DAP phase gate, we already know by now this is the statewide phase gate, and we don't want to play with it around. Make sure we get all the information necessary during the DAP phase, and the goal is to make sure we capture all the risks and constraints. We are fairly confident that the project can move forward. Footprint and impact is determined. Necessary approvals are either obtained or are in process, and outstanding issues are identified, studied, and documented. In other words, the goal is to determine we are pretty confident that the project can advance forward with the DAP level scope, schedule, and budget. And the traffic unit provides, all approval-related documentation, by the DAP phase gate. Now, I would like to go towards the design sides. The signal design. Signal design, typically the state traffic roadway engineer has the approval authority for signals. And our goal is to have all the formal approvals done by DAP. For every intersection, we try to do intersection control evaluation, whether the intersection, the signalization is the right option, or roundabout is the right option, or a new creative type of intersection. Let's say restrictive, certain intersection with certain restrictions. What we call R-cut, restricted crossing urban. T intersection, something like that. There is a specific type of, there are all different type of intersections now being developed. So just before, in the planning phase, we were talking about when Eric was mentioning that we want to be less prescriptive in the planning phase. I think that's what we are really trying to hit, because the transportation system plans are typically 15, 20 years old. If you try to be prescriptive at that time, this will be the nature of the intersection here, good luck. After 20 years, how many things will be changed. In signal design, it basically includes detection systems, signal timing design, signal phasing, emergency vehicle preemption design, railroad clearance, if applicable, and sometimes it can be pretty complicated. Illumination design, typically this is a region traffic units authority, so it doesn't have, the approval doesn't have to go to state traffic roadway engineer's office. ODOT's general policy is partial lighting at interchanges, particularly on complex geometry and gore areas. Key factors in analyzing the needs for illumination are nighttime related crashes, unusual roadway geometries, pedestrian and bicycle needs, etc. And if the safety analysis suggests that nighttime related crashes are overrepresented at a location, illumination should be considered. Typically, ASTO roadway lighting design guide of 2005 is our typical standard. Sign design, I think all of you believe on that. Signs are the most overused traffic control devices overall in the country, because its weight is still here. If the roadway screws up the geometry, and then okay, put up a sign, right? Warning sign. okay? Sharp curve ahead, okay? And you expect all the road users will use very judiciously, and they will keep themselves, safe. It's not going to happen. So, roadway and traffic, they work very hand in hand together. And why I'm saying, signs are the most overused is there are all kinds of signs. The MUTCD, this thick MUTCD document has more than 50% of the document is all about signs. Regulatory signs, warning signs, guiding signs, temporary traffic control signs, all kinds of signs. And on top of that, once in a while, we get these advertisement signs. And I'll share you a story here. Have all of you seen unmuffled engine braking prohibited sign? Okay. Amazing signs. I call them amazing sign because before you install them, there is so much noise on the road. All the citizens are complaining, oh, I cannot sleep. We need a sign here, unmuffled engine jailbreak sign. And we even did noise study in Region 3. We have our previous traffic safety investigator from Region 3 right here. He did the noise study, and there was no difference between the before and after. There was no change in noise. Even the ambient noise was higher than the actual trucks making noise. But as soon as you put those signs there, all the noise is gone. No complaint, nothing. That's why I call them amazing noise-absorbing signs. Okay. I'm saying all this because these are one of the most overused signs. And think about this here. The cost of that actual sign is only $5,000, just the sign part. The structure, $300,000. That's where the cost comes. Okay? And now, with all the built-up environment and everything, good luck finding a place to put even any extra sign there, which you need. Every day I get that request. Striping. Signing and striping go together, hand in hand. They should complement each other. And when we have extremely congested, built-up environment, in that built-up environment, you have to provide information. You have to provide room for bicycle, room for pedestrian, room for public transit, room for buses only sign, and striping. Good luck finding any space there, even for striping. And when in the rural areas, when there are no suburban areas, no congestion, it's okay. You have opportunity to do the best to provide what the community wants. But in built-up environment, we just have to play with what we have, and then at that time we really need to rank what is absolutely needed and what is desirable, could have, should have. Right? When we talk about all these traffic control devices, it comes there are some solid requirements, where the traffic control devices should go. It's not that, hey, I need striping. I need, additional, do not block the intersection kind of striping, or add another sign there. The traffic control device should be, something like it fulfills a need. There should be a need there. The traffic control device should command attention of drivers. The traffic control device should command respect of road users. The traffic control device should provide enough time to response the road users. That's how we choose and really prioritize where the sign goes, where the striping goes, where all these devices go. And if we do not look for all those options, and it just becomes an advertisement, feels good traffic control devices. And I'm trying to add here the rumble strips plan also go along with the striping plans because they also complement each other. One thing on striping, we would like to make sure, when we are removing the stripes, now the goal is to repave those, stripe removed sections, because the ghost lines, when it, afterward, if we don't, repave it, it just becomes an operational and safety issues down the road. Access management, I believe you'll have a full session tomorrow about access management. I'm just including here because we have, project access management engineer almost in all traffic units in the regions. And one thing on access management I would like to share with you is please do not make any promises early in the stage of the project. A lot of things change, and access management can be very controversial. You never know which will be resolved positively and which will be, we may have to go just again and again through iterations and legal issues. We never know. So make very few promises and deliver those. I think that would be the better one. Railroad crossing is also we need to be aware of, because sometimes the railroad clearance issues of traffic signals are concerns, and they can be real safety concerns. In Oregon, the railroad has, I believe, 6% share of freight compared to truck, water, and air. Signal designs and signal timing for railroad clearance can be particularly complex. Railroad requires application for crossings when the design is nearly 30% complete. Would like to provide the heads up earlier. And the railroad wants us to contact them if we work anywhere, 500-foot radius from the railroad. And I think we can work together to improve the working relationships with the railroad in the future years. QAQC is another component of traffic design, and there is a lot bigger initiatives going on right now in all the regions as well as state level. So I would like to say it has been given in most recent days, we have given a little more thought in QAQC process and how we would do, we are trying to enhance our QAQC process for in-house as well as outsourced projects. I would like to add a couple of stories here. One is, this utility vault here. We were working in a Mount Hood Highway project, and PGE wanted a special type of vault here, an additional conduit, and they were not. There was a lack of coordination from the early stage of the project, and that kind of caused them not to get what they were exactly looking for, but we had to work hard to at least give a basic minimum what we could accommodate during the late stage of the project. And the second one here next to the guardrail is the details. Look for the details when necessary. As what I would suggest is our designers have to be able to zoom in and zoom out all the time when to go into the extreme detail, and then when see a bigger picture as necessary. And you see in that upper picture here, many times the utilities are issues. They see the signal pole so close to the electrical lines, and imagine somebody has to go there, maintain, depending upon what the voltage of that power line is. Sometimes electricity can jump, so it can be a safety issue. And we had one scenario in Region 3 about 4 or 5 years ago. There was a big transmission line, and we had a signal next to it, and none of the electricians wanted to work in that signals because every time they go there, they feel a goosebump. There was, the higher voltage was running pretty close, and next time when we did redid the intersection, we had to do additional electrical installation there to make sure our ultimate customers, the maintenance, gets the best out of what we are designing for. I'd like to bring here a couple of emerging concepts and trends. Blueprint for urban design. We just had 2019 rollout. This is a kind of bridging document between the ODOT standards and city demands, needs, their desires. So in how we design our system in urban and built-up environment, this is really a bridging document now. We were looking for this information for many years. We were using that concept, but it was not documented. Now we have a documented elements here, and we can use that as a reference. And mostly it will be our urban standards sooner or later. NACTO design guide, all the big cities are using this. We have ASTO and we have NACTO. They were always, far apart. Now we are coming closer. A couple of years ago, I believe, ODOT considered NACTO as one of the resource document. ODOT practical design has been here for many years. We had, I think, 2009, 2010, around that time, we had that ODOT practical design guide in all the regions. We got the trainings, and I believe we are still continuing it and reporting in a regular basis. Context-sensitive design is getting more attention now. It has been there for many years, and we are, re-emphasizing. Briefly, I would like to share about this all-road transportation safety, because the traffic units gets a lot involved in from the 300% list to all the way to 100% list scoping, and during the design also, sometimes if we don't have, particularly in the first round of ours, when we didn't have enough funding, we had to down scope, re-scope, a lot of changes had to be made. Until 4 or 5 years ago, there was separate part of funding for state roadways, and cities and counties, they were on their own. The state, we used our own program, and it was ODOT safety program. Now it is all roads transportation safety, including cities and counties. There was a memorandum of understanding signed among ODOT, Association of Oregon Counties and League of Oregon Cities. The safety funding is eligible for all public roads now, and all of you transportation managers, probably you have, many of you have gone through the pain of this. And safety funding is divided into two categories, systemic low-cost safety and hotspot, which is a little bit focused more on, more expensive, isolated locations. And the focus for funding areas are intersection safety, roadway departure safety, and pedestrian and bike safety. And overall, the concept was to have a data-driven decision-making approach on safety funding. And with that, all said, I would like to say a couple of things here. Transportation project managers, the work you do is complex. Okay? You realize it. And you do not, in the morning, Ken Patterson mentioned, you do not have the resources. The resources are with, discipline managers. So in that context, you are true leaders. Basically, you inspire and make things happen together. So do not even attempt to believe that you will know everything. Okay, there are so many disciplines, there is no way you will not be expert on those, any of those. Okay? However, do not hesitate to ask questions and humbly challenge the assumptions. That's where, when you ask questions and humbly challenge the assumptions, you make people think, you make designers think, you make analysts think, all of them, all of the team members think. When people start thinking, that's where, when people start thinking and discussing, that's where the good outcomes happen. And thank you for doing what you do. Thank you.
Thank you so much, Sam. Now it's Q&A time. Who has a question? Aha, over here. Scott, do you want to get this one over here? Watch the camera.
Where we at?
You touched on something that was important about signs being the most overused traffic control device in an urban environment. I've read about some studies and locations around the world where they've done away with signs and reduced pedestrian fatalities and vehicle crashes. Has ODOT considered something like that, or trialing a no sign zone?
I wish we could. But the problem is we are in this such a strong litigative society. What is your standard? Why didn't you put up a sign there? At least my client would know, this is, what he or she is supposed to do. So someday down the road, when the technology and everything gets really better, and when we have all the automated vehicles, and at that time, probably everything will be in your vehicle, everything will be in your, device, and you may not even need any signs. Who knows? But it will be a long way to go there.
Additional questions? Oh, okay, Tamara.
So if nobody else will ask the question, I'll ask the question that I got the most as the tech center manager in Region 1. Does every project need a traffic management plan, and do they have to be amended if something changes?
Beautiful. Every stinky project will require a traffic management plan. There is no way we can avoid it. However, that very simple project may have a couple of pages of, hey, here is the project, this is the information, this is how we'll be doing, just a couple of pages. Or I-5 closure project, it will be a volume of information there. So if you ask a question to an expert, the answer is it depends. That's what you get.
If something on the project changes, does the traffic management plan have to be amended?
Yes. We try to. It is a live document. We try to update until it goes to the design construction phase, and even after that, it changes. Because contractor may have their own idea how best they can manage the traffic at that time. I'm not sure the document itself is updated, but there is a documentation of this is how it has been changed.
Yes, Ken.
Yeah, Sam, Sometimes project teams come up with features they want to add to a project, but which features require state traffic manager approval before inclusion?
That's a great question, Dan. I believe I had provided handouts material, and that says what elements, what traffic control devices are approvable by region traffic manager or engineer, and what has to go to state traffic engineer's office. And I have the handout there. Diana, please confirm. Yes, thank you.
The handouts that you submitted,
Yes.
we copied and put in all of the pad folios to those who register. So Ken, if you want to wrestle away someone's,
Yes.
you may. But it's also in the portal. All the handouts are in the portal in a folder.
Just for simplicity, typically I would like to say if it is a signal or if it is, kind of complex traffic control device, or if it is little more political nature of traffic control device, we try to keep that to state traffic engineer's office. And so that way there is a little more filtration there. One example, that wonderful sign I talked about, unmuffled engine braking prohibited, that is state traffic engineer's approval. I don't want to deal with that in the region.
Other questions? Yes, over here. Scott, do you want to get that one? Watch the camera.
If signs are the most overused traffic control device, what would be the most effective traffic control device if you have a long stretch where you speed up and then a very sharp curve?
That's a great question. The best way to do it is improve the geometry. Improve the geometry. Yeah, geometric, because you don't design for a sign, you don't design for you don't drive according to sign. Yes, the reasonable and prudent drivers, they will see everything on the road, how it goes, how it flows. They will follow everything. However, if the driver is not reasonable and prudent, then I'm not sure we can fix those. So the solution is, start from the key is make that transition very, very reasonable. Because you cannot expect someone, you are driving 65 miles an hour and then all of a sudden 25 miles an hour is your exit speed. Imagine how many crashes will be there in those situations, right? That's where what we try to do is reduce from the early stage, hey, it's coming, slow down, but we miss them. That's how geometric improvement is the key. That's why we should work so closely with roadway, and they also need to know what the traffic needs are, what the safety implications and operational implications of those are.
One more question? Anyone?
So you were talking about SPIS and how that's a 3-year look at crashes.
Yes.
So what I've learned is that you can have a location which might be on the SPIS one cycle, off the next cycle, back the next cycle, and so on. And that really makes it problematic for ever being added to the STIP as an actual project, because it might be off right before the programming cycle starts.
Yes.
But yet it's an ongoing tracked issue and location that everybody knows about, and it's popping up with quite a bit of frequency, but not quite right for the SPIS. Is there any way that's being worked around that issue so that these problem areas can rise to an actual project?
Yes, there is. Why I'm saying it is the SPIS is the data. The SPIS is the data, and the safety analysts, safety engineers, they need to derive the information from that. Okay, why I'm saying it is it's not just, if it is many times, those 5% high crash locations, I may not have anything to do with that location because those are drunk drivers, those are completely random, serious injury crash. I really don't have any solution on that. That's why I was saying mitigable by engineering measures. That's why we try to focus on, are there other top 10% locations or other locations where that funding is justifiable based on the countermeasures selected, based on the cost to correct those locations. That's how we try to see. We used to see the 3 or 4 different cycles of space, and sometimes they fluctuate. Yes, they fluctuate. Actually, I did my entire PhD thesis on how the crashes fluctuate and how we should invest our funding, how that regression to mean happens. Because high crash locations, they go down, low crash locations, they go up. That's what happens. That's what called the regression to mean. And we want to be really careful how we see that data and how get the information, the actionable piece there.
Wonderful. Sam, thank you so much for your
Welcome.
preparation and your time today. So appreciate it. Thank you.